Good.
Well done.
This is Wen Tian from China University of Geosciences, Wuhan. Wen is just taking a peat core at the moment, the top 50 centimeters. One of the analyses we'll be doing is analysing the microbial DNA in these peat cores and looking to see if changes in microbial populations correspond to changes in greenhouse gas production at various different sites, some affected by fire, and other sites that haven't been affected by fire for a number of years. This is one of our control sites. We believe this probably hasn't burnt for at least 4 or 5 years. This is Dr. Stephanie Evers. Stephanie's taking samples for bulk density and chemical analysis. And once the cores have been completed, we're going to move in to make some greenhouse gas emissions measurements with our Picarro gas analyzer for carbon dioxide and methane. Say hello, Steffi.
Hiya. It's very hot and sweaty.
It is. That's one thing that you can't feel with 360-degree videos.
Do you want me to say what chemistry we're doing?
Yeah.
So we're going to be taking we're taking soil samples down to 50 centimetre depth at 10 centimetre intervals. Within those intervals we'll be measuring changes in the carbon nitrogen content, the pH, soil moisture, the bulk density, which is how dense the peat is. We're also going to be doing drift analysis, which is a spectral analysis, and that looks at peaks in lignin cellulose concentrations. We'll also be sending them for Rocker-Veil analysis. That's a form of pyrolysis, and that approach essentially looks at the amount of energy it requires to burn the samples at different temperatures, and gives you information like black carbon content and the sort of ignitability of the peat. So there's a range of different information that we're going to get from that analysis.
Okay, let's make some greenhouse gas measurements now. Just need to make sure we're getting some nice ambient air. To do that, I've got a little iPad connected to the gas analyzer. You can see the CO2 concentrations and the methane concentrations on here. Or breathing too much. There's not enough breathe. Sounds good. So we fixed the chamber to the soil, and slowly we watch the CO2 and the methane concentrations go up inside the chamber. And the rate at which those concentrations increase is the flux rate from the soil into the atmosphere. And I can quite clearly see that the CO2 levels have stabilized inside the chamber and now beginning to slowly rise from around 400 parts per million, which we know is ambient CO2 concentrations in our atmosphere, and they're quite rapidly rising. In the space of about 30 seconds we've gone from 400 to 420, and we'll leave that down for a couple of minutes now so that we get a nice straight line to analyze the flux rate. Interestingly, we're not seeing much methane from this site. It's the dry season here, hasn't rained heavily, at least for a number of months, so it's kind of what you'd expect to see in a secondary forest site like this. Not a great deal of methane in the dry months of the year, but we'll be coming back here in January and making these measurements again, hopefully. Right, we're going to make some soil temperature, conductivity, and soil moisture measurements as well. I can get it.
When do you want to take a call from around here?